Hello everyone. Here in this video, I'll be discussing about um, beta selection rule. Okay, so yeah, beta selection rule. The equation will be written something like this: Ji pi gives rise to Jf pi, where pi is a parity and I means initial J value and f is a final J value. Okay, so how to decide it? See, we have to do the take the L values, S values, okay, and also J values. Okay, so for L values, for L for L value 0, okay, for L value 0 the reaction will be allowed. Reaction allowed. Okay, for L value not equal to 0, the reaction is not allowed. Reaction is not allowed. Right. So our L value will give us whether the reaction is allowed or not valid. Okay, allowed or not allowed, it will be given by what? L value. Okay, now comes there are two types of, like, for example, it is allowed by Fermi, or allowed by Gammo-Taylor, allowed by Gammo-Taylor, or is it called GT? This not allowed is also called forbidden. Reaction is forbidden or not allowed. Forbidden means it's not allowed. Okay, so next is what? Allowed by Fermi, allowed by Gammo-Taylor. Okay, so how to distinguish which is allowed by Fermi, which is allowed by Gamma-Taylor? See, that will be decided by del S value. Okay, that will be decided by del S. If del S is equal to 0 or S is equal to 0, that is allowed by Fermi. Alright, if del S is equal to 0, that is allowed by Fermi. If del S is equal to 1, that is allowed by GT or Gamma-Taylor. Okay, another thing, when L is not equal to 0, if L is equal to 1, that is called first forbidden. First forbidden. L is equal to 2 is called second forbidden. Okay, L is equal to 3 is called third forbidden. It will go on like that, right? So here del S is 0 is allowed by Fermi, del S is 1 is allowed by GT. Okay, so I can write somehow that if L is equal to 0, L is equal to 0, S is equal to 0, what can I say? L is equal to 0 means allowed. L is equal to 0 means no change in parity. No change in parity. Okay, L is equal to 1 means change in parity. So that means what? This will give me one, no change in parity, so this is allowed. And S is 0 means it is for me, so I can write it as allowed by for me. Is that right? Okay. Hmm. Allowed by for me. Now L is equal to L not equal to 0, S is equal to 0, what can I say? L not equal to 0 is what? Change in parity. When there is change in parity, the reaction is not allowed. That means it's forbidden. Okay, the reaction is forbidden. And S is equal to 0 means for me. So we can say what? For example, A is equal to 1. So first forbidden by for me. Again, for example, L is equal to 1, S is equal to 1. So L is equal to 1 is first forbidden. S is equal to 1 is what? This is for GT, isn't it? We have just studied. This is GT. So S is equal to 1 is GT. So I can say first forbidden by Gamma-Taylor or GT. By GT. Is that right? Is that right? Right. So let's do some examples. For example, 2 plus 2, 3 plus. Okay. So first let's check. See, plus to plus, that means no change in parity. No change in parity. No change in parity means del L is equal to 0. That means reaction is allowed. If you check, reaction is allowed. Now, del J here is what? 3 minus 2. Del J is actually Ji plus Jf to Ji minus Jf. So it can be 5, 4, 3, 2, 1. But we don't need all this value. We only need 1. Okay, we only need 1. So 1. Now del S is what? See, del L is what? Del L is 0. Here, see, del L is 0. So del J is 1. Del L is 0. Okay. So how to get del S? We know del J. We know J is equal to L plus S. Del J is equal to del L plus del S. So del S will be del J minus del L. Right? Del J is what? 1. Del L, we got 0. So this is 1. So del S is equal to 1. So del S is 1 is what? Now we have del L is equal to 0 and del S is equal to 1. So this is what? Del L 0 allowed. This is what? Del S1 GT. So allowed by GT. Did you get it? Is that right? Hmm? Yeah. Okay. Next question. Next question. I'll do this one. Try to do this yourself. Sorry. 5 plus 2, 4 plus. Take 2 minutes. Try to do yourself first. You can pause the video. So plus means what? Plus to plus. That means no change. Del L 0. That means it's allowed. Okay. Del J is what? 5 minus 4 to 5 plus 4. So 1, 2, 3, up to 9. But we don't need all this. We only need 1. So del J is equal to 1. Del L is equal to 0. Del S is equal to how much? Del J minus del L. 1 minus 0 is 1. So del S is 1. Del L is 0. That means what? Allowed by GT. Okay? Allowed by GT. Okay? So how simple it is. Hmm. Next question. Question number 3. Okay? Here, a nucleus Y undergoes first forbidden beta decay. Okay. So here JP is equal to 7 minus 2 minus 7 by 2 minus. Hmm. So you have to find what? JP for the other side. Hmm. Y is decaying to Z. So you have to find this is for Y. You have to find for Z. I mean 7 by 2 minus on the right side. What is the this one J and parity, and it's going undergoing first forbidden beta decay. Take your time. Okay, see. First forbidden means what? First forbidden means first of all del L is equal to 1. Here 7 by 2 minus 2. What? Okay. So minus means what? So Forbidden means it will change. First of all, 7 by 2 minus will become something plus, isn't it? Because it's forbidden, so parity will change. Now, now what? Del J, we don't know. Del L is 1. Del S should be what? Always 0 and 1. Okay. Del S should be 0 and 1. And here also, first forbidden. It's not given like whether it is forbidden by Fermi or GT. So you can take both for both. Okay. Del S 0 for Fermi, del S 1 for GT. So let's do it. For example, this is 0, this is 1. How much will be del J? See, del J is what? Del L plus del S, right? So del S is 0, del L is 1, 1. So del J is what exactly? 7 by 2 minus something. For example, this is x. So x is how much? 7 by 2 minus 1. That is 5 by 2. So it can be 5 by 2 plus. For what? For del S is equal to 0. I put del S is equal to 0. So 5 by 2 plus will give me what? First forbidden by for me. Okay. Now del S is 1. If I put del S is 1, del J is equal to how much? Del L is here 1, del S is now 1. So del J is but del L plus del S, that is 2. So 7 by 2 minus x is equal to 2. So x is how much? 7 by 2 minus 2. That is 3 by 2. So the right hand side can be 7 by 2 minus 2, 3 by 2 plus. Okay. This would be what? First forbidden by GT. Is that all right? Why GT? Because del S is 1. Okay. Because del S is 1. Right? Is that right? Let me know in the comments whether you understood this or not. I'll do another one. 7 by 2 plus to 7 by 2 minus. So here parity is changing. So del L is 1. That means it's first forbidden. Okay. Now del J is how much? 7 by 2 minus 7 by 2. So 7 by 2 plus. So this is a 0. Okay. This is a 0. Alright. And also 1, 2, 3 up to 7. So 0 and 1. We will take 0 and 1. Del L is equal to 1. Okay. So del S values are what? This is 0, 1 is 1, 1, 1 is 0. Isn't it? Hmm. So del S value is both 1 and 0. That means it's both what? For me and GT. Okay. Very simple. Can I write a question? I will do in this board because that one was a bit squeezy. Question number 4. A nucleus with a nucleus with a mass number A is equal to 234 undergoes undergoes alpha decays by emitting two alpha particles with kinetic energy 5.81 MeV and 5.73 MeV. These are alpha decay questions. Okay. Energy of the accompanying photon. Energy of the accompanying photon is how much? Energy of the accompanying photon is. Try this question. Okay. So two kinetic energies of the both the reactions are given. For example, kinetic energy 1 is 5.81 MeV. Kinetic energy 2 is 5.73 MeV. Okay. So here, so both kinetic energy will have different Q values. We know Q value of a reaction. Q value of a reaction, do you know? Q value of a reaction. What is the Q value? Q is equal to kinetic energy A by A minus 4. That is the Q value of a reaction. Okay. So for kinetic energy 1, Q1 will be what? K1 A by A minus 4 because same nucleus is being decayed. So K1 is 5.81. So 234 divided by alpha decay. That means that's why it's subtracted by 4 because alpha decay He24. So mass number will decrease by 4 here. So 234 minus 4. So 5.81 into 234 divided by 230. Is that all right? Hmm? So this is what? This is Q1. Okay. Next is what? Q2. Suppose Q2 will be what? K2 A by A minus 4. Okay. K2 is how much? What is the value of K2? 5.73 into 234 by 234 minus 4. That is 5.73 234 by 230. So this will give me another value. This is Q2. So the energy, what is the question? Energy of the accompanying photon. Okay, the photon energy is what? Photon energy. Photon energy E gamma is Q2 minus Q1. Alright, Q2 minus Q1. That is this one minus what was the other one? 5.81. Alright, yeah, we're doing a mistake. Yeah, this is the bigger one. This is the bigger one. This should be subtracted. So 5.81. I know this should be like the opposite one. Okay. So this is a 0.08. You can subtract these two. 234 by 230. If you solve it, you will get the answer. Okay. The answer will be 0.0101 MeV. Okay. So this was the answer. Easy question again. Two kinetic energy is given. So you have to find the q values and just subtract the bigger one from the lower one. Sorry, the lower one from the bigger one. Spin parity, I hope you can calculate. Hmm. You should remember the sequence of for spin parity. The sequence is what? One is half, 1p 3 by 2, 1p half, 1d 5 by 2, okay, 2 is half, 1d 3 by 2, 1f 7 by 2, 1p 3 by 2, sorry, 2p 3 by 2, 1f 5 by 2, 2p half, 1g 9 by 2, 1g 7 by 2. It will go on like this, okay? At least up to this you should remember. 1 is half, 1p 3 by 3 half, 1p half, 1d half, 5 half, okay? 5 by 2, 2 is half, 1d 3 by 2, 1 is 7 by 2, 2p 3 by 2, 1 f 5 by 2, 2p half, 1g 9 by 2, 1g 7 by 2. Okay. So this way, try to solve, try to calculate the spin parity of this one. How many nucleons will be in one state? This is half. So 2s plus 1, that is 2 electrons can be here. Like this, this is 4 can be here, 2 can be here, 6 can be here. This way you leave, do it this one. X 21 41. So if you do it x 21 41, that means we have to see the odd number. So odd protons are there 21. So one is half, two protons here, 1p3. I hope, I assume that you know all this. Okay? That's why I'm doing this. 2. So this is 8, 25 by 2. This is 6. Then 2 is half. 2 is half. How much is 16 now? 16, right? Yeah, 1d3 by 2 is 5. So it can be 5 here, 4 here. 1 of 7 by 2 is 1 here. So 7 by 2, 7 by 2. And what is the value of f? What is the L value of f? S, P, D, F. 0, 1, 2, 3. So 3 is the odd number. So 7 by 2 minus. Okay. You hope this, you understand this because this is L value. So parity is what? Parity is minus 1 to the power L. L is a 3. Minus 1 to the 3 is minus 1. Next, write a question. Question number 5, I think. A detector is used to count the number of gamma rays Gamma is emitted by a radioactive source radioactive source if number of counts the number of counts recorded in exactly 20 seconds is 10,000. The error in the error in the counting per second is okay. This question came in TIFR 2010. A detector is used to count the number of gamma rays emitted by a radioactive source. If the number of counts recorded is exactly in exactly 20 seconds is 10,000, the error in the counting per second is how much? So if you do this question, so number of counts in 20 seconds is how much? Number of counts in 20 seconds, 10,000, right? So in 1 second, what is it? 1 second, 10,000 divided by 20. That is, I think 500 or something. 500. So rate of detector is what? Rate of detector is actually 500 counts per second. Alright, 500 counts per second. Since the detector is counting what number of counts per second, this rate will follow the Poisson distribution. Okay. Poisson distribution. Alright, Poisson distribution. So 500 counts per second, that is actually what the expectation value of Poisson distribution. Expectation value of the Poisson distribution. Okay, expectation value of Poisson distribution. Ex is equal to R is equal to 500 counts per second. Ex is equal to R is equal to 500 counts per second. So error is what? Plus or minus variance. We know error is plus or minus variance. Okay, that means plus or minus expectation value. Plus or minus expectation value. Okay, so that will be what? Variance expectation value. Where expectation value we know 500. Should be simply what? Root over 22.5. 22.5. Is that correct? Is that correct? That is the answer, right? Yeah. So yeah. So this is a bit of revision for nuclear physics. Okay. We can have more discussion on it in the upcoming sessions. Thank you.